Hi, I'm Dapper Dan, and I like to build Web3 projects and film myself doing it. I know, crazy, right? This is the first installment of a series I'm calling Builder's Journal. So, what are we building this month? Well, unless you've been living under a rock, and that's no offense to people who find rocks comfortable, Web3 and AI is all of the rage. And like everyone else I want to know what the hype is all about. So I attended panel after panel hearing about what's possible. But this isn't a what's possible show. This is a builder show. So I started searching far and wide to find a protocol or tool that I could actually start building something with. And luckily on my search, I found Giza, which also happens to sound like my favorite Wu-Tang Clan member, but that's a side note. What attracted me to Giza was that I could use all of the familiar data science tools that I've used before, like PyTorch or TensorFlow, in combination with the popular ZK frameworks out there like Cairo and Ezekiel. But before we jump into building something, it's good to get an understanding of what this whole ZKML business is all about. So there's two main concepts to cover when talking about ZKML. That's verifiability and privacy. These are important when talking about actual ZKML use cases as well. Let's look at verifiability first. Currently, ZKML allows us to create verifiable inference. To understand what that actually means, let's look at a standard machine learning model. You have some input data and a model which has some parameters that does some computations. This is the model architecture. Depending on the model type, when combining them, you get an output or a distribution of outputs, basically a range of possible options, which is the inference process. Now, let's take an example where we don't own the model, or it's being hosted in someone's cloud somewhere. How will we know that behind the API call, there's not just a cheaper model, or maybe just a little troll answering questions really quickly? Well, to solve this, we can generate a proof of inference computation, which has similarities to proof of computation that ZK rollups use, which you may already know about. This way, when inference occurs, a proof is also generated. So you might be saying, sounds great, let's apply this everywhere to every model. Well, hold on there, partner. This is a process is computationally more expensive on an exponential scale than just deploying an ML model in the wild and getting inferences. So when can we use ZKML? Well, the advantage of using ZKML is that the verification of the proof is cheaper than executing the inference. So you need to find a place where execution of inference is very expensive and proof generation could happen somewhere where it's cheaper. And you can take advantage of proof verification being cheap. Blockchains. Computation isn't cheap or efficient to execute inference on a blockchain. We can generate proofs off-chain, take those proofs, and host them on-chain. So we have verified inference even though that didn't happen on-chain. So a little bit of ML, a little bit of zero knowledge, and boom, ZKML. So let's talk about privacy. Privacy and ZK go hand in hand like a nice glass of lemonade on a hot day. Why? Well, zero knowledge allows us to prove direct computation without revealing parts of the data that we don't want to, by generating a proof as a replacement. In a world of ML, that could be we want to keep the model private, or maybe the data that's been trained on, or it could be that the inputs to respect user privacy or sensitive data are also kept private. ZKML allows us to keep that information private while still verifying the computation. But that's enough of the lesson. How can we get building? So here is where Giza comes in. Because Giza allows you to just do ML, which is a catchy title that maybe everyone should use, but how? Through its Orion ecosystem. And at the core of Orion is an open source library that takes the Onyx ML framework, which is a universal framework for ML training models, transpiles that to Cairo, a programming language for generating ZK proofs. And you do this in one command, so don't be afraid if all of this was just completely new to you. Also, Orion is completely modular, which gives it a little bit more flexibility if you want to use other ZK frameworks now or in the future. But there's more to Giza than just Orion. There's Giza datasets, which is a convenient collection of datasets that is Web3 specific, so you don't have to go out and hunt for that. There's also Giza Actions, which allows you to have better control and logging of the flow of your application by creating actions and tasks that wraps around the Python functions you would already be using anyways to train and test and deploy your model. This is also a nice way to turn on and off the verifiability parts of your model based on your use case. And tying it all together is the Giza platform, where you can see all your action runs, logs, and deployments. We're going to be using these three things a lot more in this project, so don't worry if you don't understand how they all connect yet. Oh yeah, what are we building? Drum roll, please. With the help of the team at Giza, we're going to be building a Farcaster bot detection model. This is going to help users get a better understanding of their 20,000 followers they received overnight, which ones are bots and which ones are humans, or something like that. It's going to be a proof of concept, and we're going to be building this in real time, so we'll see where we end up. But in the next video, we're going to perform the important step in a ML workflow, which is working with the dataset. See you in the next one.